Hi guys, thanks for tuning into my channel. You would have seen from my previous videos a frame that I built for my students as a replica for them to visualise when they come to making the hip rafter, and also as a gable rafter at the other one as well. So what I'm wanting to do today is I'm actually wanting to go through a basic introduction of actually how we create that hip rafter. What I have here is, you can see, I've created a top plate. It's made of 90 by 35. I've created half lap joints, just for my students anyway. But we've practiced the half lap joints in class, and as you can see, top plates all the way around. And what I've also done is I've actually marked the centre line of this section here, and I've marked the centre line on the other side, which is where the ridge along here, the ridge will be situated, and where it meets the crown end rafter. So this is in the centre, crown end rafter meeting the ridge all the way through to the other end. So this is the hip. We'll have a hip on this side and a gable end on the other side. And what I've actually got here is I've actually got a template that I use with my students that I've created, which actually helps us assess our nominator, or actually helps us measure our 22.5 degree, which is our pitch, which is our roof pitch in this situation. So I've created a little template. It's 500 millimeters this way, and it's 207 millimeters this way, and this actually gives us 22.5 degrees pitch. I've nominated 22.5 degrees because that's usually the standard that we have. You can have a 17 degrees, you can have a 30 degrees, you can have a pitch of whichever angle your plans are nominated at. And basically we've derived to these 22.5 degrees by using simple tan mathematical formula. Tan theta equals opposite on adjacent. That's how we've derived at this. It's a great little tool. You can keep it in the toolbox, and it'll certainly help you on the site. Now, what I've done now, using my template, what I've done now is I'm actually using this template to show you that this is actually set to 22.5 degrees, as you can see through there. So that will mean that all of the other roof pitches, all of the pitch of the rafters will be at the same angle, 22.5 degrees, like so, guys. And I'll just show you what I mean. Pop that around the side, pop that through there. Okay, and I pop that through there, and that is measured. That is measured at 22.5 degrees there. That's how we get our angle, guys. That's how we get our roof pitch, guys. So I wanted to show you how we actually get the roof pitch firstly. Then what I want to go through on the next video is actually how we create, you'll notice, the bird's mouth. And the bird's mouth is basically made up of a seat, and it's made up of a hill. And the bird's mouth is ideally designed so that the weight of this roof is actually seated, or is actually transferred through to the walls and down through to the slab, down through to the foundation. Whereas if you can imagine, if we just had a roof pitch like that with no bird's mouth, this would provide very unstable roof, and it would compromise its integrity. Having the bird's mouth gives the roof a lot more integrity, a lot more stability, and again transfers the weight through to the walls. But on our next video, what I will show you is actually how we create the bird's mouth, and how we actually align the ridge all the way through. So this is my first introduction to building a basic roof frame. Thanks guys, see you on the next one. Bye.